Hello there. Welcome to Actual Electrical Contact with me, Jamie Bladen. Now, I'm just reading this book, Electric Motors and Drives, Fundamentals, Types and Applications by Austin Hughes and Bill Durry. It's a fantastic book on motors, however, it is very thick and you're probably such a lazy bastard. You can't be asked to read this. Also, it's mainly about the science and stuff behind motors, although it is an excellent book if you get into motors. However, a lot of people just say to me, what about motors? How do motors work? I ran a whole course on motors last week and people are still asking me about it. So I'm going to go through some of the basic things with motors in this series to cover. Not something as complicated as one behind me. This is the Star Delta. This is the Billy Big Bowls of all motor starting systems. Pretty much redundant now because of another type of motor starting system. But what I'm going to cover is the fundamental principle of motor starting, which is the holding contact, which you'll find in the most common type of starter there is, the Dole starter. So let's put this book down and have a look at it. First of all, let's get rid of the Star Delta. This is the big one you're going to work towards that you don't see anymore, but it's the challenge. And let's go and get something a little bit more simple. Let's just explain the basic things that are in a Dole starter. If you're on YouTube, there'll be a picture on here because I forgot to bring the Dole starter prop with me, so I can't show it to you. So watch on YouTube and there'll be a picture of a Dole starter there. Probably a picture of me holding a Dole starter, but I've got the basic components that are within it. Let me grab them and let me show you what they are and what they do in the game of the Dole starter without knocking my camera like I was just doing then. And again, and again. This is an electric motor. This is an electric squirrel cage motor. 3-phase, whatever you want, I don't care. It could be this big. It could be the size of a Ford Fiesta. This is the asset. This is what you want. You don't care about any of the other stuff like what you can see behind me. All you care about is this. And if you just put 3-phase into it, it will spin round like Noah's business and give you the rotation you want for you to do exactly what you do with it. However, if anything goes wrong with the motor itself, the cooling, the bearings, the cabling, or whatever's being used on this for the drive end, the motor will be forced to overwork and it will damage itself and you will lose the expensive asset that is the motor. But also, there's no difference having a motor that's plugged into 3-phase. You want to be able to control it. And the Dole starter does all of those things. That's its thing. That's its thing in life. It wants to start and stop the motor and protect it. Let's show you what a Dole starter is made up from. So if you're on YouTube, there's a picture of me holding a Dole starter. That particular Dole starter in that picture is the cheapest Dole starter you can get off eBay, right? Just an example. And a lot of people consider that those plastic boxes with a red and green button on the front are a Dole starter. They are not, however. The Dole starter, the direct online starter, is within it. And the bit that does the starting and the protection is inside it, although you'll see lots and lots of those kicking around because they're a simple way of controlling and protecting a single motor. However, the actual important parts of a Dole starter are here. I'm going to show you what each one is. Now, you don't have to have all of these, but there's 2 of them that you will have, and I'll start off with those. You might have a container, an adapt box, or some sort of box for it, yeah? It might be in a control panel with 500 other Dole starters, who knows? It might have a start and a stop button on it. I know it's blue, I haven't got a green one here, but it doesn't have to have them. The Dole starter comprises mainly of these components here, and I've got a couple of different ones, yeah? There will be some sort of overload that can look like this. That is to protect the motor from overcurrent in amps, and there'll be some sort of contactor that might look like this. But I'm showing you these ones for a reason. It's because these ones connect together like that into an assembly which basically forms the Dole. Do they connect together properly in assembly? Yeah, they do. That's tucked in there. Is it upside down? I don't know. Anyway, it goes in there like that. That is the basic Dole starter. An overload and the protection and the control bit, the contactor. Right, they can look like different things. You might get one that looks like this. This is called a Telemechanique or a Schneider. It's called a GV2. You might get one that looks like that. They're very common. And I'll show you a load on the board behind me now. So there's a Dole starter, look, there's the contactor, and there is the overload. It's quite an old one. That is made by... Who's that one made by? I don't know. I should look for a starter code. Anyway, it's old. You got the Siemens one. Again, that's got an auxiliary block on the top. We'll get round to auxiliary blocks in a minute, but there's the contactor. There's a cheap Chinese one, Braun and IMO. An ABB one who do a very unique design on the front. You'll see they all move in like that. There's another GV2. There's the Schneider contactors. Old style Siemens. That is an old style Telemechanique one. Then you've got like Allen Bradley ones, which are really, really expensive. There's an overload on the top. They can all look like different things, but you'll start to see, look, between these three, they all look very, very, very similar because they've got some big contacts, some little contacts, some looking off. Let me tell you what they are and explain them to you. With contactors, they all perform one job. Yeah, they've got to deal with the power. Where are they? They're here. They've got to deal with the power that goes to your motor. That's what they switch in. Now, switching the 3-phase that goes to motor. So commonly, you'll find they have 1, 2, 3. These first 3 terminals will be reserved for the motor. This is a terrible contact to show you on. Let me find an easy one and do this again. Here's a better one visually, but they're all the same inside. It's just that people have got different styles, yeah? This is a Telemechanique one that then became Schneider, but I'll always know them as Telemechanique. On the top and at the back, you'll see there's these 3 big terminals. This one, and this one. And on the top, at the back, you'll see these 3 big terminals, yeah? They're for your L1, your L2, and your L3 for your motor. They go in there on the top. They then pass through the contactor for a set of double contacts. I'll draw that on the board in a minute to show you. And they reappear at the bottom as L1, L2, L3, whatever, on these big terminals here. They are your L1, L2, and L3 that goes to motor. They are for the power switching to the motor. But to be a contactor and be useful as a contactor, you have to have a couple of other little bits and bobs on here, which are on these front terminals, which I'll show you now. First of all, you're always going to have A1 and A2. They're the coil. When you put the voltage to the coil, whatever voltage the coil is, that is what brings the contactor in and energises the big power contact. So you put voltage onto A1, A2, it pulls the contactor in, and it makes these 3 switch to these 3 and let the volt through, which is really all you want it to do. So that's got to be on every contactor. You've got to have a coil. That's what makes it a contactor. However, on a lot of contactors, you will always have a normally open auxiliary contact, and these particular ones have a normally closed auxiliary contact. You've got both. So what I've got on there is an A1, A2 for the coil, a normally open contact, and a normally closed contact. The difference between the contacts is the auxiliaries is they are not capable of switching the power that these can switch. They are just switch indicators that tell you the location of that, whether it's in or whether it's out, and the normally open one is required for doing what we call the hold in. So I've just picked another at random, which is this one. You'll see this one's a little bit different. So clearly on there it says L1, L2 and L3 or whatever. They're the main contactors. This one that's marked 13 and 14, that's your normally open contact auxiliary. It's not capable of switching what these can switch. And then the A1 and A2 are on the top. But it's got all the same things. Well, has it quite? This one hasn't got a normally closed. So yeah, can't do as much with it as that one. But it's got the power contacts, the coil, the normally open, and it's all there. It's just the same thing. Every package is different. And you'll notice that when you look at the packages, a lot of these numbers tend to stay the same and do the same thing. But get your hands on contactors, feel them, look at the drawings and that, and you'll see they have to have the power contacts, a normally open, and a coil. That is the minimum requirement for a contactor. Just to really sell what each one of these contacts is for, you've got this big comedy contactor. Look back on my old YouTube videos, you'll find 2 videos called All About Normally Open, All About Normally Closed. And I cover this in detail on there. But just to show you, look, beneath the lid of this contactor, you'll see there's some huge contacts there. They're the power contacts. They're what are switching your voltage. And on the side here, you'll see some little contacts that move when it moves, look. And they are what are called the auxiliaries. They are for doing your indications and telling your contactor where it is and what it's doing to your auxiliary system. So all contactors have the power contacts that are big chunky bastards like this, and the auxiliary contacts that are little flimsy ones like this. And that is all you need to know about a contactor, I would hope. That enables you to switch your motor, but you also want to be able to switch it on and off and protect it, which is something you don't want to be involved with. That's why you get overloads. Here's an example of an overload. That is currently in the opposition. You can turn it on and it'll let the power through. In there could be magnetic and thermal overloads, like fuses that are resettable. And when either one of them on any of the phases detects that too much current is passing through, as per the setting on this dial, it just trips off. That's as simple as it is. There's another type that I like, the Telemechanique one. Again, they're easy to see. You'll see on the top, it looks like the contactor. There's 3 contacts where the power goes in. It goes through the overload if it's switched on, and it comes out on the bottom. There's a little dial on them usually to tell you what the amp is. And then on the top there, again, you've got auxiliary blocks. So these are 2 little switches. One's normally open, one's normally closed. And they'll be in a certain arrangement when it's not tripped. And when it does trip, it'll put that arrangement out for you to use for control purposes. So with the overload, when it detects overcurrent, so say that little dial set to 4 and it's going at 5, it'll ignore the first bit of overcurrent and then eventually it will trip it off. It also provides phase loss protection, because if any of the phases, the 3 phases that are driving the motor around, are lost, because that phase gets lost, the other phases have to work harder, so it will overload. So if you lose a phase or 2 phases, it'll trip because the phase loss is recognised by the overload protection. And if you are actually overloading the motor and it's taking more than it should be doing, it'll trip anyway. So that gives you all the protection you need so your motor doesn't cook itself or burn itself, whilst also providing some auxiliary things which we've got to go into, because these auxiliary things let you know what this is doing somewhere else. Likewise with the ones on here, there's auxiliaries in here to let you know what something's doing elsewhere else. So every doll starter will contain the overload and the contactor, and they are the bits that you need to make it work. It's in the edit me, which means I've made a mistake. You notice I'm wearing the same shirt, but the t-shirt's different. One thing I got to mention is with a doll starter, it requires manually dependent reset after a power loss. And I forgot to say this in this video, so I'm going to say it now. If you've got a drill or a lathe or anything that's using a doll, if the power is lost, the doll will fall out and it will stop providing power to the motor because there's no power there. When the power reappears, it won't just come back on. You'll have to go and press the start button again. So phase loss, voltage loss, a non-automatic restart is one of the bonuses of a doll. You can wire them so they don't do that, but I'd strongly advise you think very carefully before you do that, because that is a very specific requirement. But generally, if you're using a drill and the power goes off the building, when the power comes back on, the drill won't start turning, or the meat mincer, or whatever nasty bit of kit you've got on the end of your doll. So just be aware that is a thing. Do you know how incredibly hard it is to light yourself in a studio and light a whiteboard? Anyway, let's cover the wiring diagram for the overload and the contactor as they'll appear on the drawing. First of all, we're going to draw the overload. I always draw them like this. And then within that overload, you're going to have the bimetallic strip bit, which looks like that. And you're going to have the amps, overload amps. So you've got a picture of a bimetallic strip that looks like that. Then you've got the overload part of the amps. What's going to happen then is you're going to have the buzz bars across the top, and they will come in to your overload like that. So hopefully that drawing should show you that you've got a set of buzz bars, L1, L2, L3, and you tap off into your overload like that. Your overload will have some kind of actuator on it, and it'll actuate them. It will also actuate, dotted lines mean actuation, a pair of contacts which we've got here, and we'll show them like that. One normally open and one normally closed like that, and the dotted line goes through them to indicate that there's your overload and there's your auxiliaries. Remember, these are switching the power, live 1, live 2 and live 3, and these are the auxiliaries on the other side of that. Let's look at the next bit, which is the contactor. You can have some cables that come down. Your contact's going to show some power contacts, normally drawn like that. Yeah, you're going to show that. There'll be a dotted line through it, then there'll be a coil, maybe shown like that. They'll connect to that. They'll then connect to your motor. You can look at the drawing I'm providing on the screen if this is a bit rubbish. What we're saying here is, when this coil actuates, it pulls these power contacts in, but as you already know, on a contactor, we're again going to have a normally open contact and a normally closed contact, which are our auxiliaries, which are pulled through as a wanner. So that's the whole power side of the contactor covered. The phases coming in, the supply, the protection for the motor and the phasing, the control, which is the contactor, and the load, which is the motor. So every time you're doing something like that, you've got the supply, the protection, the control, and the load. Every single time those rules apply. So now you can see how the power gets through, which we're not really covering in this video much. Let's have a look at the basic wiring arrangement for this doll starter. Let me clean that off. Right then, this is the control side of things. You've still got all the same things going off. Let me show you why. You've still got a supply and you've still got a load. In this case, the supply is the 24 volt control voltage. And in this case, the load is the contactor's coil. You've still got protection because the overload is in circuit. And the stop one's in circuit, which is a form of protection, but more likely, this bit here is your control. So you've still got those four main things you'd expect in play that are on the main side and on the protection side. This is as basic as it gets of a doll starter, and the bit people really struggle with is this bit, the holding contact. Let me take you through it with my finger, because when you use a drawing, you can always follow them through with a colour or your finger. In this case, if the 24 volt supply voltage, which is here, is healthy, then it will go down this leg and it will get to the overload. If the overload's auxiliary contact is healthy, it will pass through the overload to the stop button. If the stop button is healthy, i.e. it's not being actuated, it will pass through the stop button. Everyone gets confused when it gets to here. At this point, it goes nowhere, because this start button is open and the holding contact is also open. So that's all it does. If the stop and the overload, auxiliary contacts and stop button are healthy, the power gets to here, and that's where it stays until someone decides to start the motor. At this point, you press this button by applying pressure to it there. That will complete that circuit, and the power will go down there to the contactor coil on the relay. As soon as you let go of that stop button without this bit, as soon as you let go, it would stop. As soon as you press it again, it would start, which, as you're going to see on the video, or may have already seen on the video, that's not convenient. So what we do is, this coil is energising the contactor on the motor, but this auxiliary contact here is also part of it. So you press this button and the voltage goes down here to the coil. As soon as that coil is made, the voltage goes down here and round here and bypasses the stop button. So when you let go of this now, there is still a route for it to get through and the circuit is still completed. Thus the circuit stops running. And at any point, if you overload it, you'll break it. Or if you press the stop button, you'll break it. And that is how the basic Dole starter works. Because anywhere upstream in this area, you can break it and it will stop. And anywhere downstream in this area, you can start it and it will start. There'll be a picture of that up on the screen next. Until you can follow that through with your finger, visualise where all these contacts are and follow it through in its operation with your finger, you'll always struggle. Watch the rest of the video, but always come back to this drawing and understand this drawing. And remember, all your stops go in series and all your starts go in parallel. All your stops are normally closed and all your starts normally open. And on this chain here, there can be loads of things that need to be closed for it to activate. That can be sometimes called the safety chain. But come back to this picture, the drawing's going to be up in a minute, and always make sure you can follow it with your finger, else you'll never understand a doll and you'll always struggle to understand normally opens, normally closed, and why things are controlled like this with normally opens, normally closed. And if you can't do that, you're a fucking dick. That's it for this part. Stand by for part 2. I'm going to break it all down. So this is the first part. Part 2 will be out next week, and we'll pick up where we left off and start looking at how we wire dolls up so that they work. See you later.